Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about pin configuration of 8257 and 8237 DMA controller. So generally, there are many ICs which are called DMA controllers. Among them, this 8257 is one of the DMA controller and 8237 IC is also a DMA controller. Now, first we will see the features of 8257 DMA controller. So generally, before going to the features of this DMA controller, first we should know what is the need of DMA controller. So here, in order to have the fast data rate between IO devices and memory, it is necessary to isolate CPU, that is microprocessor. So to isolate CPU, we are using here one hardware unit which is called DMA controller. So if DMA controller is involved during this data transfer between IO devices and main memory, the CPU will get isolated and the data transfer can be performed between IO devices and memory directly. So this is the need of using this DMA controller. So there are many ICs of DMA controller. Among them, this 8237 and 8257 are the DMA controller ICs available. So first we will learn about 8257 DMA controller. So here, the features of 8257 DMA controller is, it is having 4 channels. So here, what are all the 4 channels means? Channel 0, channel 1, channel 2 and channel 3. So these are the 4 channels available in this 8257 DMA controller. So since there are 4 channels, to each channel, one IO device can be connected. So since there are 4 channels, 4 IO devices can be connected. And another feature is, each channel is having 16-bit address register and 14-bit counter register. So this 8257 DMA controller is a programmable IC. So how we can make this 8257 DMA controller as programmable IC means, because here in each channel we will have 16-bit address register and 14-bit counter register. So by modifying the bits present in that register, different operations can be performed. So not only this address register and counter register, we also have mode set register and status register. Those are the 2 registers common to 4 channels. So generally here we will call 16-bit address register and the counter register is also 16-bit. But why here it is represented as 14-bit means, among this 16-bit counter register, only 14 bits are related to the counter. Whereas the 15th bit and 16th bit says the mode of operation. That is, so in this 15th and 16th bit in this counter register will says the read and write operation. Whereas all the least significant 14 bits will be saying the count related information. So that is why here it is represented as 14-bit counter register, because 15th bit D15 and D16 bit represents the read and write operation. So these 2 registers will be available in all the 4 channels. And each channel can transfer data up to 64 KB. And each channel can be programmed independently. Why each channel can be programmed independently means, because in each channel we are having this 16-bit address register and 14-bit counter register. So by using these 2 present in individual channels, it is possible to program each channel individually. And so each channel can perform read transfer, write transfer and verify transfer operations. So how this read transfer, write transfer and verify operations can be done in each channel means, in each channel we have this 14-bit counter register. So it also can be called as 16-bit counter register. So using this 16-bit counter register, that is from D0 to D14, all these bits represents the information related to count. Whereas here, the D15th and D16th bit represents the read and write operation. So since this counter register is available in all the 4 channels, by using these 2 bits of that 16-bit counter register, it is possible to have read transfer, write transfer and verify transfer operations for each channel. And next feature is it generates mark signal. So here what is meant by this mark signal means, mark is one of the pin. This 8257 IC is a 40 pin IC. Among that 40 pins, we have one of the pin mark signal, mark pin. So if that mark pin is the output signal, so it represents when mark signal will be enabled means, if 128 bytes of data has been transferred, then automatically this mark signal will get enabled. So it is very easy to identify that the 128 bytes information have been transferred. So we can know that by seeing this mark signal. Automatically the mark signal will get enabled. And the operating frequency is from 250 Hz to 3 MHz. So minimum operating frequency is 250 Hz and maximum frequency for this 8257 DMA controller is 3 MHz. And so this 8257 DMA controller, it can be operated in 2 modes. So what are the 2 modes means? One is master mode, another one is slave mode. So here generally in the previous session we have discussed about how the DMA transfer will, using DMA controller, how the data transfer will be performed. Like IO devices will send the request to the DMA controller. From the DMA controller it goes to the CPU. Once if CPU releases the bus, it sends the signal to the DMA controller. Then the DMA controller will send the information to the IO devices. Then only the information can be transferred between IO devices and main memory. So based on this data transfer, this 8257 DMA controller is transferred into 2 operating modes. One is master mode, another one is slave mode. So when this 8257 DMA controller is operating in the slave mode, this CPU, that is which can also be called as microprocessor, and DMA controller unit will be interacting. And another mode is master mode. So when this 8257 DMA controller is operating in the master mode, in this case, the DMA controller will connect the main memory and IO devices. So this is the main difference between this slave mode and master mode. So how they are differentiated means which blocks are going to communicate. So in the slave mode, the microprocessor and DMA controller will communicate, whereas in the master mode, the DMA controller is going to communicate with the main memory and IO devices. Now, generally here we have different types of DMA controllers, but generally used DMA controllers are 8257 DMA controller and also 8237 DMA controller. And if you see this 8257 DMA controller, it is a 40 pin IC, and this 8237 DMA controller is also a 40 pin IC. Both the ICs are programmable ICs only. So just we have seen the features of this 8257 DMA controller. Now, coming to the pin configuration of this 8257 DMA controller. Here, this 8257 DMA controller is having 40 pins. So here all the 40 pins are arranged in the dual inline package. So arranging the pins in the dual inline package means here we can observe the pins from 1 to 20. at one end of the IC. At another end of the IC, we can see the remaining 20 pins. That is from pin number 21 to pin number 40. So all these are the 40 pins of 8257 DMA controller. Now here coming to the first pin, this is IO R bar. So IO R bar, it is an active low signal. So if we see the pin diagram here, all the signals directions are given. All the signals directions are given. So based on the signal direction, we can identify whether that particular signal is the input signal or whether it is acting as the output signal, or if the signal is bidirectional signal. So the signal directions are clearly indicated in this pin diagram. So the first pin is here IO R bar. So IO R bar represents IO read. And the second signal is IO W bar. So IO W bar represents the IO write operation. And next, the third and the fourth pins are M R bar and M W bar. So here this M represents memory. Memory, R is read, memory read, and the next one is here memory write. Okay. So here the reading and writing can be done from the IO devices or from the memory with the help of these signals. And next, the fifth one is here mark signal. Just we have seen in the features also, when this mark signal is enabled, see here this mark signal is the output signal. Okay. So when this mark signal is enabled, when it is going to give the output 1, it indicates that 128 bytes have been transferred. So when mark signal is asserted, it indicates 128 bytes have been transferred. And the next sixth one is ready signal. So this ready signal is generally activated by the slow devices. Only when this ready signal is activated, then only the data transfer between IO devices and main memory can be transferred. And next, seventh one is HLDA. So this HLDA, it is an input signal. So what this HLDA represents means it is hold acknowledgement. So it represents hold acknowledgement. So if you observe here, this is the input signal to this 8257. That means from where this is coming and where it is from where it is coming and going as input to this 8257 means this HLDA signal will be coming from 8086 microprocessor, because this HLDA signal of this 8257 DMA controller will be connected to HLDA signal of 8086 microprocessor. So this is the input signal from where it is coming as input to this 8257 means from 8086 microprocessor. And next here, eighth one is ADSTB. So ADSTB represents address strobe. Okay. So these signals are used to identify the or demultiplex the address lines, and it is only used to send the address. So this address strobe is having dual function because this 8257 is operating in the master mode and slave mode. So in the master mode, it will be acting as one function. In the slave mode, it will be having another function. And the ninth signal is AEN. So AEN represents address enable. So if this AEN signal is enabled only, the address data lines of this 8257 DMA controller will get demultiplexed and it will be transferring only the address lines. And next 10th one is HRQ. So HRQ represents hold request. So this HRQ is the output signal. Okay. So to where this 8257 HRQ signal is going means this HRQ signal will be going to the 8086 microprocessor. And the 11th signal is CS bar. So CS bar represents here chip select. Okay. So this is CS bar. It is active low signal. So when the signal is enabled only, this 8257 will be activated. And here 12th one is clock signal. Okay, so this clock signal is used for synchronization, internal synchronization between all the blocks. So maximum clock frequency required for this 8257 DMA controller is 3 MHz. And next 13th one is reset. So if this signal is enabled, the internal registers present in this 8257 will get reset. 8257 will get reset. And here this 14, 15 and 25 and 24 pins. So all these pins represents DACK0 to DACK3. So they are active low signals. So 4 DMA acknowledgement signals are there. So they are called DMA acknowledgement signals. Here 4 DMA acknowledgement signals will be there, and the next one is here from 16th pin to 19th pin. They are DRQ0 to DRQ3. Okay, so these represents DMA request lines. These are the DMA request lines. So here we can observe 4 DMA acknowledgement signals are there and 4 DMA request signals are there. Because in the features of this 8257 DMA controller, we have observed that there are 4 channels. Each channel is capable of driving one IO device. So that is why for each IO device, it should have one DMA request line and one DMA acknowledgement line. So similarly, for 4 IO devices, we will have 4 DMA request signals. Along with that, 4 DMA acknowledgement signals also. And the next 20th pin is ground. So it represents ground connection for this 8257 DMA controller. And next signals here from 21 to 30 here. Excluding these 2 signals, if we observe, we have the signals from D0 A8 to D7 A15. Okay, so these are the multiplexed address data lines. These are the multiplexed address data lines. So using this D0 to D7. So if you observe this signal, all of them are bidirectional. That means by using this D0 to D7 bidirectional data bus only, all the information from this 8257 will be transferred to 8086 microprocessor. And next here, 31st pin, it is VCC. So VCC represents power supply. So maximum power supply required to operate this 8257 DMA controller is plus 5 volts DC supply. And here this A0 to A3 and also A4 to A7. So totally this A0 to A7, all these represents the address lines. So the lower order address lines, that is the lower order address lines, nibble represents the selection of any register, that is whether to select the address register or whether to select the counter register. So all this information will be set by this address lines only. And the next signal is here TC. So TC represents terminal count. Terminal count. So this signal is also an output signal. So when this signal is enabled means, if the DMA controller, that means if the DMA cycles are completed, then this terminal count will be enabled. So it represents the DMA cycles have been completed. So these are all the 40 pins available in this 8257 DMA controller. Now, These 40 pins we will discuss in detail because each pin will be having different function. This 8257 will be operating in master mode and slave mode. So for some pins, based on the master mode and slave mode, the function of the pin will be changing. And here, the first signal is here, DRQ0 to DRQ3. So these signals represents DMA request. DMA request signals. Okay. So here 4 DMA request signals are there because 4 DMA channels are available. So these are the 4 individual channels, and if you observe the pin diagram, these are the request input lines. So for the pin diagram, if you observe, these signals will be indicated as the input lines. So the main function of this device is, so these signals will be used by the peripheral devices for requesting the DMA services. And so based on the priority or based on the mode of the priority, here we have 4 DMA channels. So for example, if this 8257 DMA controller is operating in the fixed priority mode, so since here the 4 DMA request lines are there, by default, this DRQ0 signal will be having the highest priority, whereas DRQ3 signal will be having the least priority. And next signal is DMA acknowledgement signals. So this represents DMA acknowledgement. So here in accordance with these 4 DMA request lines, we will have 4 DMA acknowledgement signals also. So generally if we observe here, if we consider this is an IO device, and here we will have a DMA controller. So where this DMA request and DMA acknowledgement lines will be placed means, here we will have DMA request lines, so which can be represented as DRQ line, and from this DMA controller to the IO device we will have DACK, that is DMA acknowledgement. Okay, so this DMA request lines used by the peripheral devices for requesting the DMA services. Similarly, what about the DMA acknowledgement signals means? These are the signals coming from the DMA controller to the IO devices, updating the requesting peripheral about the status of their request by the CPU. And next signal is CLK. So it represents clock signal. So this signal is mainly required for internal operation of 8257 DMA controller. So all the blocks that are available in the DMA controller, in order to synchronize them, this clock signal is required. So maximum clock frequency required for this 8257 DMA controller is 3 MHz. And the next one is ground pin. So ground signal is the supply, that is the ground for this 8257 IC. And next one is reset. So if this reset signal is enabled, 8257 will get reset. So resetting 8257 DMA controller is nothing but all the channels, that means the 4 channels connected to the DMA controller will get disabled. And next we have this D0 to D7. They are called data lines. So if we observe here these data lines, here we can see, if you observe, this is called data bus buffer. So this data bus buffer will be there in this 8257 DMA controller. So using this data bus buffer only, it is going to, DMA controller is going to communicate with 8086 microprocessor. And these are the bidirectional data lines D0 to D7 carrying the information from this 8257 DMA controller to 8086 and from 8086 to this DMA controller. So that is the importance of this D0 to D7 data lines. So these are the bidirectional data lines used to interface the system bus with the internal data bus of 8257. So here we know that this 8257 DMA controller can be operated in master mode and slave mode. So when this 8257 is operating in the master mode, the address will be transferred through this D0 to D7 lines in the first clock cycle, and during the remaining clock cycles, data information will be available on this D0 to D7 lines. And in another case, when this 8257 is operating in the slave mode, the same D0 to D7 lines will carry the command words to 8257 and status words from 8257. So this D0 to D7 signals are having different function when this 8257 is operating in the master mode and slave mode. And next, A0 to A3, they are called address lines. So generally this address lines will be used in the register organization of this 8257 DMA controller. So generally we have the address lines from A0 to A7 in this DMA controller. So among those address lines, this A0 to A3 address lines will be used to select the internal registers like 16-bit address register or 16-bit counter register. So the processor remains in the active state and are used as the address inputs of 8257. Now, so here the same A0 to A7 address lines, when this 8257 DMA controller is operating in the slave mode, these A0 to A3 address lines are used to select one of the registers inside this 8257 DMA controller. So we know that in this 8257 DMA controller, we have total 10 registers available. So 10 registers means 4 channels are there. So each channel we have one 16-bit address register and one counter register. So totally, since there are 4 channels, we will have 8. That means 4 address registers will be there and 4 counter registers will be there. So along with this, we will also have mode set register and status register common to all the 4 channels. So that mode set register is 1 and status register is also 1. So totally 2 registers. So if you make this, number of registers available in this 8257 DMA controller is 10 registers. So this address register and counter register, they are 16-bit registers, whereas the status register and mode set register, both of them each are of 8-bit registers only. So especially this A0 to A3, they are used to select the address inputs of 8257. So when this 8257 is operating in the slave mode, it is going to select one of the registers inside this 8257. So based on this A0 to A3 lines only, any one among the 10 registers will be selected. And when this A0 to A3 lines, if it is operating in the master mode, these A0 to A3 lines will be acting as 4 least significant memory address output lines that is generated by 8257. So for that also, in the slave mode it is having one function, in the master mode it is having another function. And the next signal is IO R bar. So it represents IO read operation. Okay. So reading from the IO devices. So generally, so here it is a bar represented. So it is called active low bidirectional input signal, which is activated by the processor. For this signal also, when this 8257 is operating in the slave mode, the processor reads an address register, counter register or status register. That means the processor is going to read the information from 8257 from What information is read by the processor from 8257 means the information like the information which is present in the address register, counter register and status register will be read by the microprocessor, that is 8086 microprocessor. And when this 8257 is operating in the master mode, it is used to read data from the peripheral devices. So in the slave mode, it is going to read information from registers. In the master mode, it is used to read information from the peripheral devices. And the next one is IO W bar. So it represents IO write. Okay. So this is also bar is here represented. So it is called active low bidirectional input pin, which is activated by the processor. So when this IOW bar signal is enabled, when this 8257 is operating in the slave mode, the processor writes the information to 8257's address register, counter register or status register. Similarly, when this 8257 is operating in the master mode, the processor is going to load the data to the peripheral devices. This is also IO write bar is also having two functions. One function in the master mode and another function in the slave mode. And so this is a CS bar chip select. It is also an active low input signal. So CS bar represents chip select. So when the signal is enabled, the 8257 DMA controller will be activated. So when this 8257 DMA controller is operating in the slave mode, it enables read-write operation from 8257 DMA controller or to 8257 DMA controller. And when this 8257 is operating in the master mode, it is automatically disabled to prevent the chip from getting selected by the CPU while performing the DMA operation. So this is the chip select signal having different function in the slave mode and different function in the master mode. And next one is A4 to A7. So totally we have address lines here from A0 to A7, whereas A0 to A3 are the address lines used to select the registers, whereas here A4 to A7 represents the higher nibble of the address, that is from A0 to A8. This A4 to A7 comes under the higher order bits of the address bus. So these are the higher order address lines generated by 8257 during the master mode of DMA operation. And next one is the ready signal. So generally this ready signal will be activated because of the slower devices that are connected to the DMA controller. Okay, slower devices means the data rate will be very slow. So in order to have the correct synchronization, it is possible only if you include wait states. Only if you include the wait state. Okay. And so this HRQ represents hold request. So generally this HRQ signal will be connected from DMA controller to 8086 microprocessor. So if this HRQ signal is enabled, the DMA controller, it means the DMA controller is requesting the CPU, that is microprocessor, for the system bus access. So HRQ is for hold request, which is an active high output pin. It is also connected to the hold input of 8086 microprocessor. So whenever this DRQ input is an active state and the DMA channel corresponding to it is enabled, so the HRQ output becomes activated by this 8257, which is essentially requests the processor to grant the total control of the system bus. So it represents generally, so if we consider this is a DMA controller and this is a microprocessor. So the DMA controller will first send the HRQ signal to the microprocessor asking for the permission of, asking for the granting of the system bus. So if the microprocessor is willing to give the system bus to the requested DMA controller, it is going to send the hold acknowledgement signal to the DMA controller. So in the DMA controller, we have this HRQ signal and HLDA signal. So the HRQ signal of this DMA controller will be connected to the HYLD signal of 8086 microprocessor. But whereas here, this HLDA signal of this microprocessor will be connected to the HLDA signal of the DMA controller. So once this HLDA signal is enabled, it indicates that the system bus has been granted. So it is the hold acknowledgement signal which indicates the DMA controller that the bus has been granted to the requesting peripheral by the CPU when it is set to 1. So this is what HLDA, so which represents hold acknowledgement. So if the hold acknowledgement signal is enabled means it represents the system bus access have been granted by 8086 microprocessor to the DMA controller. And the next one is here MEMR bar. So it is active low signal. It represents memory read operation. So the 8086 microprocessor is going to read the information from the memory. So it is an active low signal. Especially it is an active low output signal which is used to read data from the memory during the DMA read cycle. And MEMW bar. So it represents memory write operation. That means here, when this signal is an active low signal only. This signal is also an output signal which is used to write data to the address memory locations during DMA write operation. So if this is memory read, it happens during read cycle. If this is memory write, this operation will be performed during DMA write operation. And next signal is VCC. So VCC represents here power supply. So for this VCC signal, the maximum DC power supply that can be produced is only plus 5 volts. That is plus 5 volts DC supply. And next one is ADS-TB. So ADS-TB represents address strobe. Okay. So when this signal is enabled, it is going to demultiplex the higher byte address and data using external latch. So we have multiplexed address and data lines. If the signal is enabled, the higher byte address and data lines will get demultiplexed with the help of the external latch signal. So this is AEN. It represents address enable. So when the signal is enabled, the 8-bit latch containing the upper 8-bit onto the system address bus. So AEN can also be used to disable other system bus drivers using DMA transfer. So this AEN signal is also used to demultiplex the address data lines also. And so this next signal TC, it represents terminal count. Okay. So when this terminal count, generally it is an active high only, but it is represented as the output signal. So when this terminal count is enabled, it indicates that the total number of DMA cycles have been completed. That means the DMA controller has reached the terminal count condition. So after each DMA cycle, the terminal count will be decremented by 1. If once all the DMA cycles have been completed, the the terminal count will be decremented by 1 and it becomes 0. So when it becomes 0, this terminal count signal will be enabled. And another one is mark signal. So if this mark signal is enabled, it is also an active high signal. It is the output signal. So when this signal is enabled, it indicates 128 bytes have been transferred. So when the mark signal is enabled, it indicates 128 bytes have been transferred. So every time at the 128th cycle of the DMA, this mark signal will be enabled. So that is what the function of all the 40 pins available in 8257 DMA controller. Now, another DMA controller is here 8237 DMA controller. So generally compared to 8257 and 8237 DMA controllers, some of the features are different. Okay. So now we will discuss about the features of 8237 DMA controller. So it provides various modes of DMA controller. And also similarly like 8257, this 8237 is also having 4 independent channels. And not only 4 independent channels, in 8237, the advantage is if we want to increase the number of channels also, it is possible by connecting them in the cascading manner. So number of channels can be increased. It is not fixed to 4. But whereas in 8257 DMA controller, only 4 channels will be there. And so in 8237 DMA controller, each channel can be used in auto initialize mode. That means automatically initialization of the registers is possible in each channel. And it can transfer data from memory to memory also. But memory to memory data transfer is not possible in 8257 DMA controller. So this is the main advantage. But in 8257 DMA controller, the data transfer can be performed only between IO devices and memory. But here in 8257, along with that, we can also have here memory to memory data transfer also. Now, while transferring the data from memory to memory, single word can be written in all the locations of the memory block. So address of the memory can be either incremented or decremented. And similarly, like 8257 DMA controller, for 8237 DMA controller also, the maximum clock frequency is 3 MHz only. So for 8257 also, the maximum clock frequency is 3 MHz. And another features of this 8237 DMA controller are directly expandable to any number of channels. That means the number of channels can be increased. Minimum there will be 4. If you want to increase the number of channels, it is possible by going for cascading connection. And so just we have discussed about the pin configuration of 8257 DMA controller. Okay. So all the pins will be same in 8237 DMA controller also, but one pin will be different. In this 8237 DMA controller, we can see one new pin which is called EOP. So EOP represents end of process. So this end of process signal is available in this 8237 DMA controller. So generally this signal provides that it is used for termination of the DMA operation. So that is why it is called end of process. So end of process means termination of DMA operation. So generally this signal can be enabled with the help of external hardware. And DMA can be requested by setting an appropriate bit of a request register. And similarly, how the DMA data transfer will be happened between IO devices and memory means by isolating CPU only, in this case also, by using the signal which is called DREQ and DACK. So DREQ represents DMA request and DACK represents DMA acknowledgement. So these signals can be initialized by active high or low. Okay. So this is the pin diagram. Here in this pin diagram, only one pin is the new pin, that is EOP. Okay. So in 8237 DMA controller, all the 40 pins that we have seen in 8257 and the function will be same, but only one new pin we can observe here in 8237, that is EOP. So EOP represents end of process. So this EOP signal is a bidirectional signal which is used as the input to terminate the DMA process. That means when the signal is enabled, it is going to terminate the DMA operation. So it can also be called as another function like output to signal, the end of the DMA transfer. So here, this is the only new pin in the 8237 DMA controller, which represents the end of the process. That means the DMA controller will be terminated. The operation of the DMA controller will be terminated when the signal is enabled. So this is an active low bidirectional signal. So this is 8237 DMA controller. So if you see all the 40 pins, same pins only we have discussed in 8257 DMA controller also, like IO read, IO write, memory read, memory write, and NC represents no connection, ready, hold acknowledgement. This is address strobe, address enable, hold request, chip select, and the next 12th pin, it is clock signal, reset. Since here 4 channels are there, we have here 4 DMA acknowledgement signals, and for each one we have 4 DMA request lines. And along with this, we also have here VSS. Okay, VSS or ground. It represents the ground connection. And next one, we can observe DB0 to DB7, that is multiplexed. This DB0 to DB7 represents data bus, bidirectional data bus. And here we can observe 8-bit address, that is A0 to A7. So the function of all these signals is similar to the function of the pins what we have discussed in 8257 DMA controller. So only this is the new pin, EOP. So which represents end of the process. So this is what about the pin configuration and function of each pin in 8257 and 8237 DMA controller. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.